Hi parents, in school we are just finishing up our exploration of area, and specifically area of combined, they're also called irregular shapes. It's very challenging. This is one of the hardest concepts in math that we have in third grade. There are several, but this is one big one. I'm going to take some time to go over some problems that are available to you in the workbook, and you can go through these problems with them. After area is originally introduced, we move on to what is called a combined shape, or it's also called an irregular shape. They originally see little squares that help them to understand that we can apply little squares to the shape to find out what the area is, and that's why we get the terms like square feet, square units. So the first thing that we do is break this into two pieces, and we find the area of each part, and then we recombine. So I'm going to break it apart right here, but there's other ways you could break it apart too. First, I'm going to do this part right here. We have 1, 2, 3, 4, 5 rows times 1, 2, 3, 4, 5, 6 columns. 5 times 6 equals 30. Down here we have 2 rows, and then we have 10 going across. 2 times 10 equals 20. To get the area for the whole thing, we have to combine this area and this area because we're recombining these two shapes. 30 plus 20 equals 50. 50 units squared. We quickly move away from having the little squares, and we realize that these numbers right here indicate how many we could draw for, but we don't draw them. The problem is kids don't draw them straight. We don't always have enough room. We're trying to get to the point where it's labeled, and that's what we believe is the measurement. We still do the same step where we divide it into smaller parts. So I'm going to divide it right here. You could divide it this way as well, but we're going to just divide it into 2. So I'm just going to use the measurements that apply to this part. That's the 4 feet by the 10 feet. I'm going to use multiplication. So 4 times 10 equals 40. That's this part taken care of. I like to also write in here 4 times 10 equals 40. Then I'm going to come down here. Now we have all these extra measurements, and that's because we might decide to cut it here. But we only use the ones that are true for this section only. This part isn't true because that's the whole thing, and I've already used up some of it. This part is only for here, this measurement. So I'm going to use the 6 right here times this part because it's only for right here, times 5. 6 times 5 equals 30. I've done both parts. Now I have to recombine this amount plus this amount to get the area for the whole thing. So 40 plus 30 equals 70, and this is feet squared. The tricky part about this is that students sometimes often don't realize that they don't need this one right here because we've already figured this out. They don't need this one because that's the whole thing. So I don't need it for the way I divided it. I need this one and this one for here, and this one and this one for here. You can talk to your student about how if I divide it a different way, I'm going to use different numbers. And this one is the most complex that we get to for third grade, and it's very, very challenging for a lot of students. This one has missing parts right here. We still just need to find the area, but we also need to find this part and this part. And we do it by the idea that rectangles and squares have a quality to them that the opposite side is equal to the other opposite side. So for example, this side right here that is missing the amount right here is equal to what's on this side. What I like to do is complete this square right here, and it helps them to see all the different little squares that are in here. This one right here, 3 feet, the opposite side is right here. So this is also going to be 3 feet. And as adults, we think, oh yeah, it makes sense that the opposite side of a rectangle is equal, but kids forget that. Let's look over here. If this is the total of the opposite side, I need to take this side and this side. Add them together, I get 8. That tells me the measurement all the way across. If this is 8 all the way across, then this has to be 8 all the way across. So I have 8 feet right there. Let's do the same thing on this side. The opposite side is 8, but that's not the whole thing. We have this little part up here. I have this rectangle. The opposite side of this side that's missing is this side. That is a 2 feet because it's the opposite side. And this whole thing right here now is 2 plus 8, so that's 10 feet all the way. So that means the opposite side over here is also 10 feet all the way. We're using geometry right here. Now we still have to figure out the area of this whole thing. That's where we go to the idea of dividing this in half, or not in half. If we divide this part right here, I can say 2 times 5 equals 10. So that's for this part right here. And then I can take this side right here. I could say 8 feet right here times whatever this whole thing was. This whole thing was 8 feet. We figured that out earlier. 8 times 8 equals 64. So this part is 64, this part is 10. To get my final answer, I need to recombine everything. So I have 10 feet plus 64 feet. That equals 74 feet squared. Now, this is a little frustrating because we take all this time to figure out this side, all this time to figure out this side, and maybe we won't even use it. But the standard is the kids have to figure out these missing bits of information and the area of the whole thing. Some of you might think, why don't we figure out the whole thing and then just subtract out? That's perfectly okay. A lot of kids just in 3rd grade don't think about subtraction. So if we do it that way, we will say this whole thing is 10 feet times this whole thing right here is 8 feet. That equals 80. And then this little part that is removed is just 2 times 3. So 2 times 3 equals 6. And then I can subtract that 6 out and I get 74 feet squared. Both of those are fine. It's just that kids don't always think about this. If your kid's thinking this way or you want to show them this way, that's a plus because it's a little bit of a shorter process. So you can go either way, but we want them to think versatilely and to figure out how to do area. That's the biggest thing. If you would like to have your student practice some more, they can log into Clever and then go to my page. From there, scroll down slightly. It says practicing area, and this is a link to some more problems. They can figure out each problem. I would have them sketch it and label it and figure it out before they enter the answer in the box. And then it will tell them if they are correct or not.
Whoops.